Hey everybody, this is Larry. This is me doing virtual contests. Weekly contest 481. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this one. We only have a couple of contests to go. So yeah, hit the like button, subscribe button, join me in Discord. I'm still a little bit recovering from my sickness. So we'll see how that goes. Yesterday's attempt at the bi-weekly was a disaster, but today, let's see. We're still a little bit from catching up, but otherwise, no notes. Let's just go. Okay. I was just calculating the thing, right? Is it 2790? Hopefully there's no edge cases. Okay, because I didn't really think there would be one. Which is maybe not a reliable thing, but okay. Non-empty and consistent equal characters. What does equal characters mean? They're the same? The person who wrote this probably did not speak English. Non-empty. I guess it always has to be non-empty. Okay. Okay, right, and then now still the equal thing is still bugs me a little bit, not gonna lie. Something like that. I think 11, 13, 0. Why did I write C there? I usually write C and S for consistency, but this is by character. Okay, not by okay. But luckily, nothing has to change that much. Yeah, no, let's actually be more consistent with past Larry, so that these things are more precise. Okay, 11, 13, 0. Okay, I was also hoping for no edge cases. Huh, there are two hard problems today, so it'll be interesting. I should also clean my monitor a little bit. It is a little bit dirty, but okay. Nums and for band. Choose two, swap I and J. Okay. I see. Almost like what's it called? Derangement. But so we have to minimize number of swaps. I mean, this is probably gonna be a cycle length thing, right? And it's only impossible if all the numbers are. It's impossible if there's a pigeonhole thing, right? Pigeonhole and permutation cycle problem. It's annoying though, for sure. Can I think of this any other way? I mean, trying to do this is not hard. I think you just kind of like, or not minimizing it is not hard. I don't think, but minimizing it is a little bit tricky. But I mean, I think my ideas are right, but it's just trying to think of how, the best way to implement it. Isn't this just one swap? Oh, it is. Okay. I'm trying to get some inspiration from the ideas. I mean, the thing we would do is probably sort them in some way. I think sorting them in some way probably gives us a structure to be a little bit better, and then it'll just maybe be greedy in some way, but it's still maybe a little bit tricky. Okay, so we sort by forbidden. Okay, what is the idea here? Okay, these two are bad, so then you just swap these two and these two and these two and, well, maybe not. Well, this one and this one, and then no, they just suggest these two and then these two. I guess that makes sense. That's what maybe what I was trying to say. I think I got a little bit confused with yeah, you just do these two and oh yeah, okay, maybe I got a little confused, but okay. So the idea maybe, okay, I guess for me visualization is easy. I mean, it's easy to implement. Okay, I mean, there's only 4 ways to sort this, right? So hopefully one of them makes sense to me. I mean, 2 of them are symmetric. You really only sort by forbidden or nums, right? And then maybe there's an invariant that we can build on. So this is forbidden, so then what do? I think permutation cycle is the only way to do swaps, but I don't quite know how to do it. Forbidden, I think, is just so it's one of these kind of number of ways. I'm not quite sure though. So here we have 3 things that are forbidden. When we sort by this, we go, okay, 4. We can swap another one that's forbidden. So maybe we have like forbidden things. Because if you swap 2 forbidden things, then you get rid of 2, so you always want that, right? And it doesn't really matter which, well, I wouldn't say it doesn't matter which one, but then you have this thing, right? And then that kind of reminds me of what's it called? Euclidean cycles, kind of. That even makes sense. I mean, okay, so there's a graph of some sort. And a swap, is it a bipartite graph? Is it? Those 4 can swap with any of these 3. But then this one cannot be in either these, and this one can swap with this one. So it's not a bipartite because this creates a triangle, right, of sorts, or even the anti one, maybe. Or well, 4, 4, 5, 5, 6, 6 is definitely a triangle. You could just swap any of these. 1, 2, wait, how does this work again? 1, 2, 3, 2, 1, 3, 2, 3, 1, right? So, okay. I'm trying to think whether they're just lying to you. I mean, that's definitely one optimal move, but we don't even care, right? Because it's just we have 3 forbidden things. And we can just swap them, right? In 2 moves no matter what. So then the question is, okay, there are a lot of two, so there you have to figure out there are a lot of one swaps. There are a number of swaps that makes it 2 better, a number of swaps that makes it 1 better, and then that's it. So every swap at least should improve, except for this stuff where there's I think there's just pigeonhole, right? Like maybe you can have ends. So otherwise you can always do it, I think. Well, they have to be in both for this to be true, so I don't have to check both. Okay, so if k, if ns of k, so the space is going to be n minus f of k. So if this is greater than this, then we return -1. Otherwise, trying to think. Do you okay? Let's say there's another 4-4. Then the 4-4 cannot participate in this cycle. No, because you want as many 2 pairs as possible. So you wouldn't want this to be a cycle anyway. It's just that here, you ran out of things to do. So, yeah. And as long as this doesn't matter, because this, after you change 2 of these, then you could also argue the state changes anyway. So then this one can just change over anything. I mean, because of pigeonhole would have already made it impossible. If this is possible, you can just switch 1 with any other one. Really, you can make that argument for optimality without solving it, maybe. Okay, let's do it. I mean, I'm honestly, this is very like greedy oriented, so I wouldn't be surprised if I'm just wrong, right? Can you always do 2? Except for when there's 1 left. Is there some forbidden things? No, I mean, you can. Okay, so if there are 2 things that are different, then you can always do it. Because obviously if they're the same number, then you cannot always. Okay, so then now, then it's just like, okay, so then, okay, maybe doubles. No, but you need the also, I forgot to actually finish writing this for some reason. I just noticed this. Okay, right. And then this is the thing where if you have more than half of it, then it's just impossible, which is what this checks anyway. So I think we're covered there. If not, then it is just oh, this is impossible if it is half. So then now this is the max number, right? So the max value of f. Max. So the max of this so this is the total count. This is the max. How does that go again? So it's going to be so other is equal to c minus max, and then so moves is going to be equal to min of max and other, right? And then moves we added by the total number minus okay, let's just say p for pairs. Did we do that? I might have already done that. Nope. This is what happens when you name things terribly. Okay, right. So then now moves is equal to the number of good pairs together. Otherwise, after that, you do because that's the max minus, even max minus p. I think max minus p is a little bit cleaner. No, I mean it's fine. Max minus p. They're the standalones, but of course you want to make sure that this is at least positive, and then that's it. Maybe we set 1 to -1. Do not expect typos. Oh right, that I kind of knew. Okay, so if they're all non-forbidden, then we just return 0, right? If thing for f is equal to 0, then we just return 0 because everything's already good. Why would you change anything? Okay, so this is 2, but I put 1. Why? I did 1 1 1. Max is 1. So maybe that's, oh, this is only one case. Okay, that's good. Actually I messed up on the case analysis. I thought this actually encompasses it. Okay. Okay, so let me just, I'm trying to be too clever about this, but we can just write out the formula. If max is greater than equal to other, then yeah, then this is fine. Else, so max is less than other, then that means that everything can yeah, so return c plus 1 over 2, so just the number of pairs round up. Okay, am I confident about this? Not at all, but hopefully okay. I think I messed this. Oh, this didn't catch it. Oh, because I messed up. This should be the other way around. Because the forbidden slots, but there are number slots, maybe. NS. Is this enough? I'm trying to think. I mean, actually, it should work the other way. Why didn't it work the other way? The number of one, so you have one space, and this should be 2. So this should be 1 is greater than 0, right? Why is this wrong? I confused F and FS. Okay, so that would have been wrong anyway. Okay. Wow. This is what happens when you label things. Use better variable names, everybody, and Larry. Okay. YOLO submit. Okay, so that was actually right except for the typo. Which actually, honestly, surprised me a little bit. I thought, but that's the problem with like, not a problem, but that's my problem anyway. With case analysis problem is that you're never too confident you got all the cases, and when you do, even when you do have all the cases, you have typos like this, and you don't know if it's because you missed a case. But okay, silly mistake, but that's okay. Okay. Let's focus now. Q4. Pew did this one. Wow, Pew did this one really fast. And okay. I mean, I don't know. I keep saying that and hoping that they catch the cheaters, but maybe they don't. Okay. You have a tree, undirected, nodes, edges. Nodes, edges. Group. I don't know why I'm reading so slowly. I think I got a little distracted by the last problem. I'm still thinking about it, not gonna lie. Okay, focus. Alright, okay. I mean, this is just standard tree definition. Groups of I, okay. U and V are considered the same group if they're the same group, okay. Interaction is the number of edges on a unique path between them. Okay, I mean, that's just... Okay, I mean, that's just like the distance, right? The sum of interaction, so the sum, I don't know what they call it, why invent a new term if it's just distances, right? Why are you inventing a new term? You're not even like, and everything else is just abstract things anyway. Like, why would you invent a new thing? Okay, so this is and then sum, okay. Is my n is 10 to the 5th. I'm trying to think. There's gonna be at most n groups, right? Oh, group is only 20. That changes things. I think it's just rerooting, right? Yeah, I mean, I think it's just rerooting. I thought we did a recent rerooting problem, right? Then you do it once for each group. I think that's the idea. Which is why I looked at the group and I was like, well, I don't think you could do it if the groups are big, but okay. And then now, yeah, it's just 1 to 20, right? So, done is equal to set for I and range of n. Is it 0 based? It is. Good. If group sub I is not in done dot add group sub I, and we just yeah, I'm trying to name it honestly, but it's fine. And then we just root it at F, right? Alright, let's actually write it out, and maybe the group ID, maybe that's fine, right? Easy to pass along anyway. Okay, so then we just write out how I usually write these things. Except for usually I don't get it wrong, but maybe I do today. Actually I get it wrong a lot, but just still not usually. Okay. Okay. How do I write? Okay. I think someone taught me how to write it in a cleaner way. I was reading notes on it the other day, so maybe I'll try as a new science thing. Okay, right. Would I return? Okay, so the sum of all of these, right? So it's not just, you don't have to break them down by group or anything. Maybe something like this. I don't know. It's not quite right. I think it's fine. You don't need to be precise. Maybe. I think it's. I think I'll just change it real quick. This is not going to be right. There are optimizations I can make here, but I don't want to prematurely do it. It should be fine. Just 20 times n instead of n. Maybe it's not that fine, but it's a constant cost compared to incremental. There's no complexity wise. We'll see. I don't know. I'm not confident. But okay. So this is fine, right? Oh, there's a peak cost. I guess that's the rerooting thing. Excuse me. I still write it my way, I think, but okay. Okay, so what's the new peak cost? Peak cost is basically cost of 2 of node minus cost of v plus peak cost, right? I think maybe that's roughly right. Oh, F2. Alright, well, that's going well. No, it's because I forgot to do, is this +1? No, I mean, it is this +1, but we have to, I didn't think about how to filter it out. I mean, this part should take care of itself, but this part, actually, how do I filter it out? Huh. So I can just do, I guess it's just like the depth of the thing. Maybe you can. I don't know. Maybe this is awkward. I don't know. If something like that. I don't know if that's quite right. I mean, it's definitely not right according to this, but how do I get 9 though? Oh. Okay. I mean, so that's a actually not sure. That oh, I think I get it, but something's off. Because it shouldn't be 3, 3, 3, right? Like 0 is 1 plus 2. 1 should only be 2, so something is wrong anyway. 2 should be 3 is fine. So that's why I was inconfident why it is wrong. Okay, start at 0. Node 1 is 1. But this should be minus depth, I think. That's why. And I didn't calculate this cost correctly because we have to shift it by whatever. That's hard. Actually, I thought it would just take care of itself, but actually not the way that I did it this way. It's not that bad. We just have to think. Okay. Maybe? Okay, so because it goes to 1, and then now no, I think this is fine. Okay, maybe not, but now we have to use it. Cost of 2 is that even true? Oh, this probably could be true actually. Yeah, but we just have, but this updating is not true. Okay, so this minus these, which is probably fine, plus p cost. Maybe not so fine. Maybe I have to do a p count as well. p count is just going to be counts of node minus counts of re. Okay, so that's the number of nodes. Including this node. Okay. Plus p count for other parent counts. Right. And then now p cost is the parent cost, but every time you do it, you have to plus p count for one step further. Something like that. But I don't know how that would fix. Oh yeah, right. But I don't know how that would fix yeah, this answer, because it's just would give me more if anything. I mean, I think the idea is right, mostly right, maybe not. But I'm not doing it right, that's for sure. How do I handle this case for the cost? So with non things, we don't care. This seems maybe okay. This only works for the root though, right? Maybe. Okay, let's actually print this part out. Maybe we could see for ourselves. Okay. For 0 is fine. For 1, G is okay. G is fine. P cost is 0. Yeah, okay, because that's nothing else. P count is 1. That's true. Is it true? Yeah, because it counts the thing, right? So then 1 is going to take the cost. P cost is actually 0, so cost of node is already wrong, maybe, because it's at 1 distance away plus 2. Okay, now I actually did this as a hack because I didn't have counts, but I think I could just use counts actually. Because then now plus counts of 3 because they're all 1 step further away. Okay, we don't need D anymore. Okay, now you're just still going crazy, but that's even more crazier, really. I don't know how that got worse actually. Okay. Okay, no, the P cost is 2. What's the actual cost? Well, I feel like this should not be hard, but I am not doing well today with this one. Okay, 3, 1, 0. That looks right actually. So then so this cost is the parent cost. Maybe I'm off by 1. Okay. So it goes cost is 1 plus P cost. P cost is 2, which is wrong. P cost should be okay. So this cost is 3 minus 1. Well, 1 is just wrong, right? Oh, I think this also has to be okay. That is funny that ironically by adding a cost it subtracts it out enough. Okay, why is this so big? I thought I don't know what I'm printing anymore. Maybe oh, that's just the input. That's not part of the cost. Okay, so this is actually okay, so the cost actually, maybe that is off. Anyway. Because it doesn't count distance to itself, I suppose. Okay. So then now this is 310. But then now 3 minus 1. How does it know? Oh, the subtraction from the re part. Okay. So this part is wrong. Is this part... This is the cost plus counts of 3. Three, 1, 1 is still wrong though. Because this is this cost contribution because we have this thing. And then now P count. I mean, this is 1 is wrong, right? Okay, P cost is 0, which should be right. By itself has to plus P count. I think this should be handled here. So something here as well. Oh no. Okay, so count of node is going to be 3. This is 2. P count is 0, so this should be just 1, right? And there is only 1. So that's right. It is right, but this thing doesn't... The P cost does not factor in because this P cost should be 1. P count does not factor in. No, the P1 is right here. Okay, so so this is the right P count, but the distance is messing up by not counting it. Okay. I mean, I don't want to guess, that's why. I mean, I'm trying to reason it out. So, okay, so this is the contribution. This is the P's contribution. But it doesn't have the contribution for the node itself. Which I guess we just have to do. I guess it is just this part of it. Okay. All right. Groups up. That's enough, because this should factor that in, but it's just one more distance, right? But then now this is right, but this is really wrong. This should be a basic one for tree rerooting, but I am really messing it up. This was not enough. Okay, so why do I have 4 here? I have 4 here because the P count is 1. This really could be a, just n minus count. I don't need to pass this actually. Yeah, just have one fewer thing to do. Well, we can check it actually. Well, it's not just n. I don't know. Why should we 3, 2, 3? So P cost is at 4, which basically seals this thing. Okay, so this is 0. Oh, this is maybe this doesn't have a peak cost. Oh no, this is just to pass in the peak cost. Okay. Is P count correct? Then P count seems to be correct here. So it should be correct or up to date. So okay, so this is what is this? Why did I have cost 2? I'm trying to figure out why I have cost 2 here. Did I fix it? Maybe not, but I fixed the first one at least. Because 323 is what I was looking for. Why did I have cost 2? Cost 2 is the cost with the parent. Why would that factor that in? Because you already factored that in here. Could I have used that way instead? Maybe there's a formula with that instead. But yeah, okay. Well, is there a formula with that instead that makes it easier? Because it's still wrong. I mean, this one I knew it was wrong because we have to divide it by 2, but the other one doesn't really match out. Even this one should not. Oh, that's okay. Actually, I forgot. I wrote it this way so that I can so I could be lazy, and then I just was too lazy. Okay. Okay, now everything's divided by 2 above, so then we can just divide by 2. Is that good enough? 4, 2, 3. Honestly, I don't know. I'm going to do an optimization. So that was just a silly mistake. I can't believe I messed up a for loop. But yeah, maybe what I could do is I don't feel so good about how much space I'm using or time I'm using. So I could YOLO submit, but this should be like 2 minutes to add, so we can play around with it. We could theory craft later. Yeah. Yeah, we could do it this way just to get the first one, whatever. That's fine. And then here we go for J and GS of group sub I. I think that's why I kind of wrote it this way, but oh, not a range anymore then. Okay, is there a timing? Oh no, it's just fast. I do still have print statements that I definitely need to get rid of before it gives me other errors. Where's my, okay, there it is. That would be funny if I just took a long time because I had this confusion. Okay, well this is just wrong as well. This is the same input as before, so I mean it's example 1, slightly different. So okay, so there are definitely still things that are. Oh no, it's not the same. What's different? Wait. Oh no, this is 4. Let me read this. Well, what would be? Why is this different? What? Well, I mean, it's the same, so it should be 4. Well, why am I different? That part actually makes no sense. The peak cost should be the same from 1 and so the peak cost is different and therefore just wrong. That doesn't even make sense. Why would it be different? That doesn't make sense. Isn't this the same for well, oops. Okay. Fair enough. Oh no, I was looking at the. Was I looking at the wrong case? I guess I was just looking at one case. This is something different. That looks very similar to what I would have want. This is still wrong though, of course. But at least the peak cost is consistent. Okay, so 1 P other P count is just fine. Peak cost is clearly not. Okay, so the cost is 2. minus this thing, which is, this is going to be 1, this is going to be 0, so this is 2, so this is 1 plus so this is 2, but p cost and p count, which is true. This is a little bit wrong then, but how? I mean, it's definitely wrong on this part, because there's no, this part should not matter, or the D part is pretty straightforward to understand. Why is this wrong? We subtract 1, but is that the contribution to the answer? For cost 2, it is. So the other map is going to be 1. I see. I see. I think the way that I should write this is actually plus and now we don't have to worry about D. Yeah, I think I didn't do the distance formula right for the extension. This is, none of this extends to the distance. This extends all the distance of the nodes by 1. I thought p count would do it, and p count does do it, but only for the p cost portion. So that's why how I figured it out. Now is it right? I mean, it's slightly closer. Wait, let me double check the input, because that happens to me sometimes. Okay. I mean, I was imprecise. That's definitely not right. So, and I think the D was my way of doing it, but I didn't really think it through a little bit. I mean, I know that I got accepted. I just didn't, or I thought about what it was for that particular node, and it always felt a little weird, because that felt weird for sure, which is why I was very quick to get rid of it. Once I realized that this is how you represent the number of nodes that are not in the, I mean, everything makes more sense once you visualize it, and I'll go over the explanation in the explanation video, which, depending on where you're watching this, you know, maybe either you already seen that part of it, or you know, if you're just watching the contest video, then well, wait for that part of it. But yeah, because this is just all the other things that are not in the parent. And once you figure that out, I mean, it's not hard. It's just, it's almost like a tricky case analysis, and I probably could have written this out to be not a one-liner. That would make things a lot easier as well. P count also doesn't need to be a P count, really. I mean, it does get used here, but like I said, you could, P count could be a calculated value. This just, and the reason why I don't like it, even though we had to think about it, and it's correct, is that, well, you have to think about it and you have to verify that it is correct. Yeah, okay. Yeah. Wow, that's a tricky one. Definitely, you know, a smarter person could have gotten it in 4 minutes, I think. Right? Is that it? Let's do a quick retro. Sorry, I was just getting some water. Oh yeah, this one's fine. This one is pretty straightforward, right? I think. Though I still don't like the equal thing, right? Like, equal does not mean the same. Or in English, it's different. I don't know. Just sounds very awkward. Why did I get wrong answer on this one, right? Why did I get a wrong answer on this? Oh, I had a typo on this. I mean, I'm actually happy about this one because I did work it out. It was kind of tricky, but I just kind of had a typo. I mean, it is what it is. And this one, well, I didn't have a typo. It was an imposition at the very least. But also just not correct in it. I just didn't think it all the way following through. For some reason, I didn't think of. Well, I thought this would take care of it, but kind of. I didn't actually think that. It doesn't make sense if I did think that. I think the cost too. Maybe there's a easier form of cost too, but maybe that doesn't make sense either. I don't know. All right. But yeah, yeah, okay. I mean, I think overall the contest was okay. People did very well. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.